All right, let's get started. So today we're going to do a C++ conversion of a project that I did prior to this. If you're not familiar with Unreal, I suggest you start with something a little bit more basic in Blueprints, but I'm assuming you know how to make a Blueprint project and sort of know how the Unreal system works. So I'm just going to load up the project that I had built in Blueprints, and we're going to do this in C++. So we're going to duplicate this, but using C++ instead of just Blueprints. So let's take a look at the project first. So let's not worry about the extraneous stuff. It's basically a blueprint, and we're going to look at the first person pawn. We're going to look at the player controller, and we're going to look at the game mode. Those are the three things we're going to recreate in C++ for now. So let's take a look at the pawn. So our pawn has we're going to be dealing with movement. So we want to replicate the movement, we want to replicate the POV, we want to replicate the jumping, and we want to replicate the sprinting. We've got a sprint added to it. We've added a camera component to it in Blueprints. We're going to add this in C++. And this player is using inputs. So just a input asset. I'm blanking on the name. Those are called, let me just check, input mapping context. That's the input mapping context. And then we've got some input actions for jumping, looking, moving, and sprinting. And these are the input actions. And we will be doing these in Blueprints, but accessing them in C++. And then we'll show you how that works. And then the last thing we're going to do is our game mode's sort of unnecessary. We don't have to do it in C++ because I've got nothing in it quite yet. But, we may as well just create one that'll be essentially an empty C++ class. And then we're going to have a player controller in C++ as well. And the main function of the player controller for us will be to add the mapping context for it. So we're going to do this in C++. And that's pretty much all we're going to get done for the first part of this tutorial. So again, I'm assuming you know a little bit about Unreal, and I'm assuming you know a little bit about IDEs and how to set them up, because this video is not about that. But I'll cover what you're going to need to do to get started. So first off, you are going to need to have, I think the easiest way of getting all your IDEs up and running is to just install Visual Studio. So go down and download Visual Studio 22, and I believe the community version is free, and that's fine. And then when you set it up, you're going to go to your Visual Studio, Visual Studio, and it's installer. You're going to go to the Visual Studio installer. And in this Visual Studio installer, you're going to make sure that you've got everything that's in the Unreal page. So on there, they've got a page called Setting Up Visual Studio. You can just Google for that. You can go Google Setting Up Visual Studio, and you will get, I should put Unreal 5.6, and you will get a link to that in Unreal. So setting up Visual Studio, and essentially we need to modify the installer and make sure we have these assets loaded. So let's go take a look. So I've selected modify the installer, and under my workloads, I'm looking for .NET Desktop, and that's right here. .NET Desktop is ticked off. Desktop development with C++, that's right here, that's ticked off. And then .NET Multi-Platform UI development. I believe that is WinUI application development. So that's what I believe they've renamed it to, and this seems to work for me. Then we want a few things: C++ profiling tools, address sanitizer, and Unreal Engine installer. And if I go here and look on my right panel and I open up my optional, I will see my profiling tools, my address sanitizer, and my Unreal Engine installer. And the last thing I want to make sure is I got Windows 11.NET installed, so I can go to my individual components and go Windows 11, and I have my Windows 11. So I've got everything that is required to install it. Now, I really like using Rider. I think Rider is great. So first thing I do is I set up Unreal to use Rider. So for students, you can get free access to Rider. Otherwise, it is a paid package. And you can request it from JetBrains. So you can Google again Rider Student Pack and get a free download. You could use Visual Studio as well and sort of ignore any of the Rider stuff I talk about. But that's sort of my preferred workflow. So I'm going to assume you have all of that. So we are going to get going on this quick little tutorial. Well, maybe not so quick. So let's go to Epic Games Launcher, and I'm just going to install the game to the Games Launcher. So I'm running 5.6.1 right now. So I'm going to load that up. And I'm going to put this into Perforce. So I am going to go. It's going to be a game. It's going to be blank. It's going to be a C++ game. I'm going to put it in the folder I want it to be in. So I want it to be in my class. And I believe I have a folder here. Let me go to Perforce. So I am using Perforce, and if you are using Perforce, it's a good idea to get it set up. So I'm going to set up my Perforce. I'm going to get latest. Should have my folder here. Yeah, I see it. So that folder is in UE5 class 2. So UE5 class 2 and my name. I'm going to select that folder. And I am going to call this project, this is going to be first-person shooter template. So we're going to recreate sort of the template, a simplistic version of it. FPS template C++, CPP. And I'm going to put it in my Perforce directory. So if you are using Perforce, make sure you're logged in. Make sure you put it in an active Perforce directory. I do have some Perforce videos with Unreal if you want to know how to set it up. But let's just get going with this project. So one of the first things I want to do is make sure that Unreal recognizes the IDE I want to use. I believe that carries over from project to project, but I'll just show you where that setting is located once we get Unreal loaded. But I'll be right back as soon as this loads. Okay, we've got Unreal set up. Everything worked fine. If you do have errors, you're going to have to address them. But in my case, everything loaded up. And I'm going to look for IDE. And I'm going to look for where I set up my, maybe it's called editor. Where do they put that? It's going to be under, where would it be? Source control. Editor revision control. Okay, I see that. So we're going to go to editor revision control. And is this really all there is to it? There is no setting for Rider. Maybe that's something that we don't have to do anymore. I thought I had to pick. But I had to pick that it was set up for Rider. Let me go to ChatGPT and see what it says on this. So project settings. I'm going to look. And it says Rider for Unreal Engine plugin installed. Okay, so I've got to make sure that the Rider plugin is installed. There's a plugin. I forgot about that. Okay, let's check that out. Let's go back to Unreal. And let's go to our plugins instead. I'm going to go Rider. And I've got Rider and Rider Link installed. Okay, so if you don't, you're going to need to install the Rider plugins. I've got the Rider plugins and then editor preferences. Oh, it's in editor preferences. That's why I can't find it. So editor preferences, that's why it carries over from project to project as well. Editor preferences do affect your project globally. So we're going to go to editor. No, we're going to go to source control. Nope. What's it called? It's called editor preferences general source code. All right. Source code. And there we go. Source code editor. And we are going to, if you're on Visual Studio, pick Visual Studio 22 if that's what you installed. Otherwise, I'm going to select Rider. And that's the control we're going to use. So I'm going to go back to my project settings, and I'm just going to start by setting some basic settings of my project. So then I'm going to give it a description. I'll call it project description and the project name. I'll use the same thing. So I'll call it, this was, what did we call this? This was called FPS template, CPP. And I'm going to copy and paste that to the project name. The standard Moby games that I use. And the website I've got is school website that I teach at. And then for the copyright notice, I'm going to use the MIT open source copyright. So I'm going to go grab that and go MIT open source license. And grab that, copy and paste it. And I like to use this one because this is a learning exercise to share with the entire community. So not really mine. So I'm going to here and replace year and copyright holder with my name and the year, which is 2025. Mark. There we go. Okay, I've done the project description. I'm going to create a simple level. So we're going to go new level and empty level. And I'm going to go here. I'm going to create a levels folder. So a new folder called levels. And then I'm going to save this level in that folder. And I'm going to call this prototype. That's all we're going to do. We're just going to be prototyping in this level. So let's add some lights. Let's go to window and environmental light mixer. And I'm just going to add all the outdoor lighting that we would have. And I'm going to go in my content drawer, turn on my engine content, and I'm going to look for my flooring, which is called floor. And it's SM template map floor. So I'm going to make a copy of this and then bring it into my content folder. So I don't like using assets directly from Engine because I might change them and then I'll change it for every project in the engine and then no one else sees my change. So especially when I'm using source control. So I'm going to duplicate it and I'm going to drag it into my content folder. So it's actually in my project, in my source control settings. So I'm going to go here, put it in my content folder, and I'm going to make a new folder called static meshes. I'm going to move that file into the static mesh folder. Okay. Then I am going to drop that static mesh into my world. I'm going to center it. So I'm going to go to my details panel And in the location, I'm going to put it at 0, 0, 0. So it's in the center of the world. And we're going to keep this as our middle tile. So I'm going to create a 10 by 10 grid, I believe. So we're going to change our snapping to 1,000. That's the size of this piece. So I can go 1, 2, that's 3, 4, 5, 6, 7, 8. Actually, we're going to do 9. We're going to do 9 grid pieces that way. And then I can select all my grid pieces, and I can Alt select this and copy it 1, 2, 3, 4. And I'm Alt clicking and letting go of the mouse 5. And there should be 81. Oops, if I get the number right. There should be 81 pieces. $72. And then 81. Okay. So that's a 9 by 9 grid. Let me go above to the top and take a look. And I'm going to go into lit mode. 1, 2. And I can sort of see that it is square. That looks square to me. So I'm going to organize my outliner a little bit. I'm going to go here on my templates, and I'm going to grab these, and I'm going to move them to a folder called floor. And then I'll close this. And then I'll put all my other assets right now into a folder called lighting. It's there. So I've got a lighting folder and a floor folder. I'll go back to perspective. And I've got my level, and I'm going to hit save all. Okay, we're going to create our first C++ class now. We're going to create our player pawn that we want to use. So we're going to go here in Tools and to New C++ Class. And we're going to pick a character class. So that inherits from pawn and actor. So it's got all the movement we need for bipedal movement. So this is the easiest one to start with because it's got so much done for us already. So what I'm going to do is I'm going to go into this folder, and I tend to create a private and public folder. So I'm going to go private, and I'm going to go public. And then inside the folders, I'm going to create another folder called pawns, in case we had multiple pawns eventually. But right now, we're just going to do the one. But I'll create a folder for it just to be neat and organized. So I'm going to create a pawns folder. And then I'm going to go back to my Visual Studio. I'm going to select my public pawns folder. And I'm going to call this is going to be FPS pawn. So a first person pawn character. So we're going to create that class, and it's going to take a little while. So I'll be back when it's done. As you can see, it's compiling. It takes a while. Okay, it says it succeeded. That's good. When I first did this, it did not. I did not have my folder naming properly figured out. So I'm going to go to Writer, and should have a solution open. Does it look like I have a solution open? It does not look like I have a solution open. So what I can do is, whoops, there we go. Nope. I do have my solution. So what you could do if you don't see it, or you closed it, you can go back to your uProject file. And, oh, I see it has not created one yet. Let's just go. This is template. Oh, there is a solution file right there. If I go Show and Explore, you'll see it more clearly. And that's the solution file. So you could just load it from here as well. So we're going to go to our content drawer, And we should now see in C++ classes that we have a FPS pawn. That's great. So the next thing we're going to do is we're going to inherit the pawn. We're going to create a blueprint out of it so we can sort of see what we're doing and we can compare it to how our blueprint only project works. So most of the time, the team is going to be working with the blueprints, and we're just going to code the core support in C++. So we're going to right click here. We're going to create a blueprint class. So actually first I'm going to create a blueprints folder. So new folder called blueprints. I go back to my pawns and I'm going to create a blueprint class based on FPS pawn. I'm going to call it BP underscore FPS pawn class, put it in my blueprints folder. And now I have a file with what I would get if I created a character class in Blueprint from scratch. The capsule component, that is the collider. The arrow component, that's the direction the player faces in. This is only in the editor. This does not carry over on a build in the game. The mesh for the mesh character was going to leave empty. And then the character movement component that has all the movement and physics for the player. So I'm going to leave all that alone. And then we're going to commit to source control. So we're going to save all. Go to my revision control tab. I'm going to view changes. I've got no changes to view, or no, hang on, an uncontrolled change list. So I've got my map and my pawn. Okay, so I want to reconcile my assets. No, that doesn't work. It brings in all the engine assets. What I got to do is I got to manually, I think, first I got to turn on revision control. It's my first problem. So I've got to go in here and turn Perforce on and connect to my class, which I believe is WinLaptop 2. I want to double check that name. And yep, that is the name of the workspace that I'm working in. So I'm going to go here and then I'll check my content drawer. And I want to add this to revision control. And I don't see, oh, or I'm on my C++ classes, but I don't see anything. So I want to mark for add. I want to mark for add. And I want to mark for add. Where's revision control? There it is. Mark for add. I think I have 3 files marked to add. And I'm going to go to my view changes now. And I have 3 files to commit, which sounds right. It does not do the C++ files. So I can just do the ones in the content folder. So let's go here and go submitting. Player pawn character created in CPP. All right, I'm going to submit that. I've got no errors in my submission list. That was a clean submit. So now I'm going to close it and I'm going to start a project from scratch and sort of talk about some of the practices that can happen. Sometimes you put files in the wrong directory, or you want to move them, or you want to rename them, and that means you have to rebuild your project. So I got my pawn.h, my pawn.cpp, but if you go to open your solution and it's not working or it's not finding a file, sometimes you just have to rebuild your solution file. So if I go here to explore, when we're starting up a project, let me just quit Writer as well. Let me leave Writer, leave you, leave everything, and then just start from scratch. So a good practice is to delete your intermediate folder, your binaries folder, and force a recompile. It's not necessary, but often you have to rebuild the solution, and sometimes the compiled files and binaries and blueprints and intermediate are out of sync. So you've got to recreate them, and that's just by deleting the solution. You don't actually have to delete it, but I'm doing it just to show you that I go to my options, and then I go to, oops, show more options, and then I generate Visual Studio project files. and that will regenerate my project files. So if I rename my C++ files or to move them to a different directory, I would have to go through this process. Otherwise, the solution won't know where those files are. So it's going to properly create my Visual Studio solution, which I'm loading into Rider. And I load up Rider, and it takes a while. It's going to say loading project for about a couple minutes. So I'm not able to run the program yet. So it's going to say loading projects. And in the meantime, I'm going to show you how to submit your code inside of Rider. So inside of Rider, I've got these red files. That does not mean that they're not compiling or they're bad. It means that they're not checked into source control. So I need to go in, and in your settings, there is a version control and perforce, and I have mine set to on. I'm using my environment variables. I'm using in login authentication. I've got my show branching history, show integrated change lists, and find ignore files. So what I'm going to do here is I'm going to right click on the folder, on my source folder, and I am going to submit these files to the directory. So I'm going to go submit, and it's going to say, hey, you've got all of these files that Unreal created when it created the game that you need to submit. So I'm going to select all of them, all the config files as well, and I'm going to submit them. Whoops, I've got to put in a comment. So this is first submission with player pawn started. Spell it correctly, Mark. All right, I submit it. Okay, that's good. So I've submitted my 11 files, and then I submitted from Unreal. So I can go here and refresh and just do a quick, I am going to check it that I have nothing that's not reconciled. So it's got a few things in, it's got a VS config file that shouldn't be there. That should be in my P4 ignore file. I should be ignoring that. And then the template CPPU project I should be submitting. So let me update my P4 ignore to have that config file. Thought it did. So I'm going to check this out. I'll go to my P4 ignore file. And if you don't have one, it's a good idea to use a P4 ignore file so you don't have all the things that you don't need in Unreal working. So it was the, what was wanting to config? It was, I've forgotten. I'll have to go do that again. So I go up here and I go reconcile offline work, and it was .vsconfig should not be there. It should be .vsconfig, .vsconfig. Oh, vsoconfig. That's not good. That's not spelt right. That is .vsconfig. Okay. So I'm going to change that, submit that back, misspelled. vsconfig in ignore file. Submit it. Did that not, did I not fix that? No, .vsconfig, okay. Let me try that again. Let's go here and go reconcile offline work. No, vsconfig is still there. Okay, what is going on? Why did that not cover my, is that not working? Did I not hit save on that? .vsconfig, that is set that way. That's interesting. oh, now I get my P4 ignore says save, and it's not going to work because I've not got it checked out right now. So I'm going to cancel that. I'll check that out again. I mustn't have had it saved. And I'm going to save it this time by going like that and going save. There we go. Now it's there. Now I'm going to submit it. And this is like fixed. Spelling mistake of .bs. VS Studio in ignore file. All right, that's submitted. And now I can reconcile. And nothing to be reconciled. All right, there we go. So that's, oh no, I didn't do the right folder. I need to do this folder. That's my project folder, and it's got the U project that it wants to submit, and that's fine. I guess Unreal did not submit that. So we're going to submit the U project file. All right, so I'm up to date with Perforce, so I'm good. So what we want to do now is we want to start the game, and we can start the game from the editor. So there's this play button up here. Visual Studio will have something very similar, and you hit play, and it's going to load Unreal so we can get back to where we were before. So we're going to start by controlling our player and handling our inputs. So we're going to create an input action for movement, or we're going to use the WASD and the arrow keys to move around. So I'm just going to wait for this to load, and we'll speed up time, and I'll be right back. Okay. So we're going to use the new user input tools for Unreal. So we're going to create a folder. And we're going to call it input. And then inside the input, we're going to create another folder called input actions. Or we could just call it actions. And in the actions folder, I'm going to create a new input action. And this input action will be for movement. So we're going to call it IA for input action underscore move. And we are going to make one small change to it. So we're going to open it up. We're going to go in, and we are going to change this from a bool to a vector 2D. So this is meant to be for a controller or joystick, which is a 2D axis. But we're going to use a keyboard for now to fake that 2D axis with four inputs, actually 8 inputs. We'll do WSD and the arrow keys. So change this to vector 2D. We're going to hit save. And this is added to the game. And what I'm going to do now is I need to, in C++, get access to this. So I get to find some way of getting this from into C++. So I'm going to create a variable in our C++ code that I can now assign this input action to. So we're going to go to our player pawn header file. If you don't know what a header file, I suggest you look at some C++ videos. There's lots of great ones out there. But this is where we declare all our variables that are going to stay in scope when this class is created, instantiated. So I'm just going to go to my notes here and go to player pawn .h. There we go. And I'm looking for what I created. So I created a variable called move action. So I made it private. So we're going to make it private so that no other class can read it, because this is really just part of the player pawn. And we're going to call it, it's going to be a U input action pointer move action. Now, it's not recognizing this type because we've not forward declared it. So what we're going to do is we are going to forward declare this class. So we've got to include it. No, we don't have to include it. We're just forward declaring it. So we're not going to include it. I find it better to include the classes in the CPPs where we actually use them and forward declare the header files. This avoids having problems where we've got files that are loading each other's headers and we get a whole bunch of errors and problems with that. So having forward declarations and then actually inputting the header we need in the CPP file where we actually are using it in the definition is useful. So I'm just going to go, instead I'm just going to go class, I'm going to forward declare it so the compiler knows to find it. So the compiler is going to look for this class, which it is linked in this project, and it's going to find it, and it's no longer red. So now it's found that input action. It's called move action. And then to compile, I'm going to go Control-Shift-B is a good shortcut for compiling. It brings up this page that then shows me the compile status, and it's going to go building. And it says it's successful. Yay. So I'm going to my player. And now my player pawn should have open that blueprint editor to the full editor. And it should have what did I call that? I called it move action. It should have a move action that I can assign that action to. Now I can't find something called move action. So how C++ communicates the blueprints is through Unreal's reflection system. So anytime I want to edit anything in a blueprint, I do have to include a macro. And in this case, the macro is uProperty. It is a property. It's not a function. There's ufunctions and uProperties and uClasses for that matter. The compiler created the uClass for us here. That is our class name. We can go through that in a few minutes here, but let's start with uProperty. And we're going to go, it's a blueprint read write. So the blueprint can read and write this property. We need to write to it because we need to add it. It's edit anywhere. So anywhere in the editor or in an instance, it's editable. Whoops, no space. So this makes it blueprint read writable. This makes it editable in both a blueprint and in an instance in the details panel. And then category is going to be enhanced input, because that's what it is. So it's going to be in a little drop down called enhanced input so we can find it easily. And then since I put it in private, I've got to say allow private access. Otherwise, it won't compile. And this allows me to put files that need to be added in the editor into a private class because I do want to hide it. So I do have a typo here. I still have something wrong. So let me just see, where is my problem? Blueprint read write. Oh, edit anywhere is spelled. It's not right. Okay, that looks correct. So now I've got this header, and this should expose it inside a category of enhanced input. So let's compile. And I think it's compile. There we go. So let's go back. Let's go in the editor. Let's collapse our categories. And I'm looking for enhanced input, and I'm looking for move action. So you can see that it's created this input action, move action, and the editor's already said, I know it's this input action, so I'm going to give you this drop-down menu, and I can just assign IA move. So the C++ code doesn't know I've done this, but the blueprint derived version that I've derived from the C++ now has access to this move action. And the C++ code will get a link to it when this is bound with it in the game. So I can use this in C++ code, and it'll try and use the one that I've assigned the editor if I've remembered to assign it in the editor. So that's very important. All right, let me look at my notes. All right, let's create a game mode. We're not going to do anything with it, but let's just create it in case we do want to use it at some point later on. So we're going to go to Tools. We're going to go to New C++ class, and this time I want a game mode. So I'm going to use the game mode base, and we're going to go to public, and I'm going to create a new folder. And this folder will be called Unreal Core. So I'm going to put the player controller and the game mode in a folder called Unreal Core, since I use those in all our projects. So I'm going to select that folder. And I'm also going to go in and create one just in case it doesn't create it. I have a feeling it doesn't. So I'm going to go to my project. Actually, I can do that in Perforce. I can just scroll down to private and show in Explorer and create a new folder here. And this will be called Unreal Core. So I have a private and public version of that. And I'm going to go back. I'm going to select Unreal Core, which I have already. Okay. And I'm going to call this FPS game mode. I don't need base. Just makes it a bit long. So FPS game mode. I'm going to create it. Okay, so that's created a game mode where we don't need a constructor, and we're just going to leave that alone because we might come back and use that later. But for now, we're going to leave that alone. We're going to go back to our game, and we're going to create another one for a player controller. So we're going to go to our, I'm going to mount that there. Did I not save my level? Oh, I did save my level, but I didn't adjust it in my, I don't have it loading up. So I'm going to load up the level that I had there, and I'm going to go back to project settings. We are going to go to maps and modes, and I'm going to put this level as my default when I load up. So for both my startup map, my default map, that's what I'm working on now. So that's going to work for me. I'm going to go to Tools, New C++ class, and this time I'm going to create a game player controller. I can do it in C++. So I start a C++ class, and again, I'm going to go to the public Unreal Core folder, and I'm going to call this FPS player controller. And we'll have to wait a while as it creates that class again. So we've got a game mode in our player controller and our C++ classes. So let's derive some blueprints from them. So let's create another folder here. Create a folder, let's call this pawns. And let's create another folder and call this Unreal Core. And let's move, whoa, Unreal Core got put in the wrong folder. Right there. Let's move the pawns into the pawn folder. Check it out for Perforce. And then I'm going to generate blueprints for the game mode and for the player controller. So this way we can assign items in the editor and then access it in our C++ code later. So we're going to go in here, and in game mode, we're going to go create a blueprint class. This is going to be in Unreal Core, and we're going to call this BP_FPS game mode. And then we're going to do the exact same thing with player controller. Unreal Core, BP FPS player controller. So notice it's the same as the C++ name, except I put BP in it. And I'm going to, in revision control, mark for add. Revision control, mark for add. So it adds them. And then those are marked for add. So I'm going to save everything, go to revision control, and just in case it crashes, I'm going to submit it. I don't want to lose work. So I'm going to go here, and it's got a whole bunch of stuff that I've been working on. Blueprints, 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 input actions, first person template. Let's see what that folder is. Source files. Okay, it is actually going into the source files and submitting. That's new. I didn't think it did that before. So that actually might work. So we're going to go here. We're going to go submit change list. And this is going to be, essentially we just created a game mode and player controller in C++. We're going to submit that. I'm going to go to Perforce and just double check that it got everything. So I'm going to refresh. And I can delete this. This is just empty now. Don't need this change list. And I'm just going to go in and check to see that there is nothing that didn't get added. Nope, it did get everything. Oh, that's good. So it actually does the CPP files. I didn't think it did it the first time, but maybe once I've checked in that first batch, it does it. That's great. Okay, so we've got our player controller, got our game mode. Now, what I'm going to do is I'm going to go to my game mode. So we're going to go to our Unreal Core. We're going to open our game mode. And we're going to assign the default pawn class is going to be BP FPS pawn. So the blueprint derived version, because that way it can take all the work we do in the blueprint, as well as the C++. We get the benefits of using either C++ or blueprints. And if we declare all our variables in C++, we can access everything in our C++ file, which is what we've done to date. And then our player controller class is going to be the BP FPS player controller. All right, so I'm going to go compile, save, and I'm going to look at my notes, what I did next. Okay. So I did something very similar. So since we do our mapping context, if you remember, I showed you in the other game. Let me just go back and show you. In the game that we're sort of mimicking here. So have it here. It's FPS. No, it's not that one. It's not this one. Let's go. It's one of these. One of these I had it. It's Fallen Rail class. Nope. It's not it. It's yes, this is it. And it's the FPS. Let me load this up. Let me just put the dock this here. Whoops. Oh, that's weird. Just try and dock that. No, I can't. Oh, yeah, I can. All right, and I'm going to show that level design, and I'll show you what I mean. So it's not a good idea to have two projects open. In fact, if I have this other project open and I try to run it, it won't compile. It'll give me errors. But I just want to show you the context settings we need to access. So we did in the original project, we activated the controls in the player controller because the player controller persists. We might kill off the player pawn and we still want to control something or select a menu option, so we don't want our controls to go away. So we're gonna initialize our player controller inside the player controller. And in this case, we did it in, we put our mapping context right here. We got the enhanced input local player subsystem, and then we added that mapping context. So we're going to do this in C++. So we're going to need to create a variable and assign this mapping context, which we're going to create inside the engine. We can create it in C++, but there really is no benefit to doing it. And it sort of breaks the beauty of the system of being able to assign things in our blueprints rather than hard coding them in C++. So we're going to go back and we're going to go to our file. And if we looked at our player pawn, we had this move action. So what we're going to do instead is we're going to copy and paste the template, and we're going to go to our player controller.h. We're going to go private. Whoops. And we're going to call, this is going to be a U input mapping. Whoa, I think that is capital I. U input mapping context. And then we'll call it input mapping context. So what does Unreal put U? That means it's a struct. So I'm going to forward declare it. So U input mapping context, or I have to put class to forward declare it. So the compiler looks for that and it found it, or at least Ryder thinks it's found it. So this U just means it's a struct. So it's a structure, and I usually call my variable names right after the type dropping the U struct. So it's a U input mapping context struct that I call input mapping context. And this, if I compile, and then again, I put it in category enhanced input because it's all got to do with inputs. So there's no reason to call it something different to be consistent. So we're going to compile. We're going to go back into the game, and we're going to look at our player controller. And we're going to wait for it to compile. Is it still going? I think it's still going. Nope, it's done. It succeeded. So I should have an enhanced input here. Let's just minimize this. And there should be a enhanced input. And here, oh, I don't have the mapping context. So I got to go back to my content drawer. And then in input, we are going to create a new input mapping context. So we'll call it IMC underscore default. So this will be our default controls. Maybe we'll have other ones later on. And then I'm going to mark to add. And now I should be able to go to my player controller and assign that enhanced input here. So my game mode has that player controller, and my player controller has IMC default. Now I got to make sure that that player controller runs. So if I just go in here and let me put down a player start. Let's go here. Let's go player start. And I'm just going to go to the center of the map and hit the end key. Oh, I did get the center too. I got the center a bit off. Anyway, I'm going to put it in the center here. I can fix that later. I can fix that now. I can go top down. Should have put that in the center. So I can go top down, grab my floor, grab all my 81 floor pieces, and I can see where my XY axis is, and I can actually cut it in half. One, two, three, four, 4.5. 1, 2, 3, 4, 4.5. There we go. That looks good. And now if I go to my player start, I can put it in the center, and it should be somewhat centered in the world. Over here, I'm going to bring it up. I'm going to go end. Oh, I got it snapping to 1,000 units. I'm going to go back to 5. I forgot to reset that. And there's my player start. So if I hit play, I notice that in here, I've got default pawn and I've got player controller. So it's not loading what I've created because I have not added them. I've not added the game mode to this level. I can do it two ways. I can go to my world settings, which is here, or Windows world settings, or I can make it project wide. Go to my project settings, go to maps and modes, and then in game mode base, go BP FPS game mode base. And that's the one where I've added the BP FPS pawn and the BP player FPS player controller. So if I go here now and I hit play, I should scroll down and I should see I have the BP FPS pawn, the BP FPS game mode, and the BP FPS player controller. So perfect. I've got everything that I need. So let me look at my notes here and we'll move to the next step. So we need to initiate the subsystem in the player controller. So that is, we're going to do that next. So we're going to go to our C++ code. And we're going to go to our player controller CPP. Okay, there is nothing here. So we are going to have to declare a player start. So our begin play. So in our blueprint, if you remember, that was in a begin play event. So let me just grab that blueprint again, just so you can see it. I'll start typing it in, and then when it loads up, I'll show you what I'm doing. So we're going to go under, I'm going to go virtual void. So this is an overridden class that they've written called begin play. So we're overriding that base class. And then in Rider, I can go to context actions and I can go, nope, it didn't come up. There should be a way of it generating the solution for me or filling in the CPP file, but it's not coming up yet. That's all right. I can do that manually. So that begin play is trying to recreate, well, that's the first person pawn. I don't want that. I might want that later, but right now I want player controller. So I'm trying to get access to this event. So this is when I hit play, this runs once. So I want this in C++. And that's what I've done. I'm overriding this class and I'm adding to it. So I'm going to close this. And I'll go here and I'll see if, yeah, generate definitions. So it finally came up. That's going to generate the definitions in the player controller CPP for me. So it is the definition for the class. And then this super just basically runs whatever's in the parent class. So I'm overriding it, I'm adding to it, but if I run the super begin play, it's going to run everything that it ran in the derived class, which is a good idea. And you'll notice with most of our overrides, we're going to be running the super of the same name of the function. So in this case, it's a super begin play. So we're going to now go, we're going to get the enhanced input subsystem for the local player. That was that input subsystem. So we're going to go U enhanced input local player subsystem. And I don't think it has the, and it's a pointer. So we're going to get a pointer to that subsystem. And it's going to be to U local player get subsystem. U enhanced input. Okay, I'm going to just copy and paste this. Don't know if I spelled it right. And then get local player. So I need to get the class for that. So the include for that is going to be pound include, and it's basically enhanced input subsystem, whoops, subsystem.h. And as you can see, this all of a sudden gets recognized, but my get local player is not right. I've got that in the wrong spot. There we go. So this gets access to the local subsystem. And now what I can do is I can always check to see if that pointer is valid. So if it didn't actually load it, it would be a null pointer and it would crash if I tried to access it. So with pointers that potentially are null, I always want to check them first. So I'm going to check that pointer, and then we're going to add the input mapping context. Now we didn't create it here, right? We didn't assign it. It's assigned in the blueprint, but since this inherits to the blueprint, it's going to get assigned, and the C++ code will get a valid link. And if it won't, well, nothing bad will happen because we're checking to make sure that all our inputs are valid. So we probably want to also check that input mapping context has a valid, that I didn't forget to assign a variable to it. So I can go add the input mapping context to the subsystem. So it's going to be subsystem and add mapping context. And we're going to add the input mapping context with a priority of 0. And we might want to go if input mapping context, just to make sure that I assigned it. Because if I leave it blank, then it's going to crash. So I want to avoid that and always check my pointers to make sure they're not null. I could put a print on I could log the else condition, but I'm not going to do that right now. I'm going to press Shift Control B to compile. Actually, you know what? We will let's create a log. Let's do that. Let's create a simple log. So we're going to go UE log. And I've forgotten what the exact syntax is. So I'm just going to go here, go to ChatGPT and just go basic UE log. So no variables, just a straight string. And I'm just going to copy and paste it. So I'm going to go there and create a UE log. So it's going to be a log temp. It's going to be warning. So warning will make it yellow. So it'll be quite obvious. And then essentially I'm going to go valid input mapping context. So I'll know if it's loaded or not if I don't see this message. And maybe a warning is not right. Is it display? What is it for if we don't want a yellow warning? What is it called? It's display or something. It's called display. There we go. So display. Can't spell. Ooh, I've got insert turned on. All right. So I'm going to compile. And now when I run, I should see if I've assigned that mapping context, which I'll show you again. I'll remind you where that is. Let's close this up. And let's go back to our game. And that mapping context would be on our player controller, which is an Unreal Core. So if I didn't have this assigned, I wouldn't see that message. So I'm assuming I'm going to see that message when I hit play. So I'm going to go here, I'm going to hit play, and I'm going to go to my output log. Whoops. Did it crash? Whoops. Go to my output log and scroll down to the bottom. And let me clear the log. Let me actually pin it so I can dock it in the layout here, just so it stays. And then I can clear the window, clear the log, and I can hit play. And do I see? That would have been valid input mapping context right there. So it's working. Yellow would actually make it easier to see for the sake of this video, but it is not an error. It's actually a good thing. So I'm going to leave it as this log temp for now. So that's what we've essentially done what we did in that blueprint by adding that mapping context. So now we should be able to start mapping our controls. So what we're going to do is we're going to go to we've got our IA action. It's a 2D input, so like a controller. So we can move the player on 2 axes, which is what we want. And I'm going to go to my mapping context, and we're going to add that IA move. And we're going to add our controls to it, just like we did in our blueprint. So I'm going to add my up. So let's go 2, 3, 4, 5, 6, 7, 8. So this is going to be up, down, left, right, up, down, left, right. So WASD and up, down, left, right. Now for up and down, we have to, it reads X and then Y, so we have to swizzle it. So for S and A, we're going to have to add a modifier, and that modifier is a swizzle. And you can see if I open up the index that it changes the order to YXZ, which is what we want. We want it to read Y first because we're just reading the keyboard. So this is the Y axis we want to read. So that is correct. Normally it would read XYZ. So we swizzle up and then down, we have to add 2 modifiers. So since it is the Y axis, we need to swizzle it. But also it's going in the opposite direction. So we need to multiply by -1, which is negating it. So this will make it from +1 to -1. So S will be +1, A will be -1. And then on our D, we're going to do absolutely nothing. And then on our, our A, oh, did I just do it on the wrong one? Oh yeah. I just was off by 1. W is up. This should be just swizzle. Oops, did I do it? This should be swizzle. This should be swizzle and negate. A is left. This should only be negate. There should be no swizzle. So just a negate, because that's going left, and then D is going right, so there's going to be nothing. And then up is going to be swizzle. Down is going to be swizzle and a negate, just like the S key. And then left is going to be a negate, because X comes first, which is correct. We don't need to swizzle it. And then right does nothing. And then that mimics A, which is negate, and D does nothing. That's right. So I should have all our input settings set up. It should be initializing. We've got that statement printing. So now we can go and we can bind that event. So let me show you. Let's go back to our other project. And I'll show you what we're going to try and do. So we had on the movement, we would get this That's our ducking. Where's our move? Our movement's up here. We would get this IA move in our blueprint. We'd get this enhanced input event. So we've got to do this in C++, and then we're going to add our movement input to that for our 2D vector. So how do we do that? We're going to go to our, we're going to close this, and we've got to basically bind an event. So in C++, it's a little more involved. So I'm going to save my work. Look at my notes. So I've got to bind an event that's going to call a private function that I'm just going to define in CPP. So I'm going to go to my pond.h, and then in private, I'm just going to make a function, so a void function. It doesn't return any value, called move, and I pass it a const f input action value, a reference called value, capital V, doesn't matter, but that's more consistent. So I'm going to bind to this, and I'm going to just define an empty, oops, it doesn't come up yet. Eventually it will say generate definition, and I'm just going to generate a definition here. I'm just going to put a print statement every time I touch a controller. So for now, I'm just going to put in, let me just go to my pond.cpp. I'll put in a UE log, and it's log temp. And it's going to be will it be a warning? Let's try to get a warning, because I'm not going to leave it. We're going to get rid of it. So this will just make it easier for you to see. So it'll be a warning, and it's going to be text, and this is going to be user input. So we're going to log this every time this bound event, and that we can double check that our binding is correct. And then to actually bind it, we've got to go and I'm just going to move this next to my CPP file. I got to go to our pond.h, and we're going to use a function called, this is called, find it here, setup player input component. So this is where we're going to, this is the function where we're going to set up all our bindings for our controls. And this again is a class created by Unreal, so it's not ours. So it's a virtual void. We're going to override it. Setup player input component class UI. Why is it not finding it? Do I have to include that class? No, I don't see me having to do it. Setup player input component UI input component. Whoops. Player input component override. And it doesn't, whoops, I didn't spell that right. It does not like my setup. It says it's a private method. Oh, right, I should probably make this public. Nope, that's not what's causing a problem. It's not implemented. Setup player input component. I'm pretty sure this is what it's called. Set up player input component. Oh no, that just means it's not implemented, but I don't like the override. It sort of says function, especially, but does not override a base class member, which means it's not finding it. which bothers me. I wonder if I've got this signature correct. You input component. Let me generate the definition. Go back. And that error persists. It's going to come out here. I'm sure it's going to say it can't find it. I wonder if I included it in my header file in the other project when I did this earlier. So let me just check my header file. Let's go to the CPP file. Maybe I do need to sign it. Let's go put that over there. And enhanced input component. Yeah, I did have to do so. I have to add some includes. So I have to add, so I'm going to in the CPP file, or do I have to do it in the .h? Yeah, I have to do it in the .h file because that's what's causing me grief with, no, it's no longer saying it here. That's interesting. So maybe I can put it in the pawn. So we're going to go include, and this is going to be enhanced input component and include enhanced input subsystem. I don't know if we need the subsystem in this because we were putting it in the other file. Let me not do that. Let's just do the enhanced input component. Let's see if that compiles. Nope, it does not compile. It basically goes and it does not like void pawn overload move. Okay, let me take a look. Let's see what's going on. Got to forward declare that struct. So I've got to go struct f input action value. I can forward declare that struct so that it can actually read that type. And it still doesn't fix all my problems. It's not overriding any base class methods. I'm still getting that error. All right, let me throw this error into ChatGPT and see what it tells me. Go into here. Not quite. It's not coming to me quite yet. It will pop in my head at some point. UI input component, I spelled wrong. Oh, it's U input component. It's not UI. Mark silliness. Yeah, just a dumb spelling mistake I didn't see. So it's going to be U input component. And I got to go to my CPP and do the same thing. A U input component. And then we're going to build again and see where I get to. Nope, still some errors. Okay, saying I'm doing the same thing. Okay, I thought I fixed it. I've got set up UI U input component and U input component. So U input action, input action value, U input component. Where did I go wrong? U input component, virtual void setup player input component, virtual void setup player input component, U input component. Come on. UI input component, line 20. Okay, it's pretty obvious, but I'm not seeing it. Oh, that's not what I wanted. I'm still getting the override error on the base class member. Because I'm doing it on the player controller. I should be doing that in the player pawn, shouldn't I? I should be doing this in the pawn. I think I've got it in the wrong class entirely. That's the problem. So what I'm going to do is I'm going to just delete it from the player controller. This is, I am not doing this setup player input component here. I am doing it in the pawn, which is right here, which is where I've got it. So I've done it in both places for some weird reason. You input player component. Let's see if that works. Ooh, all right, good. All right, let's close this up and then close this up and then close this up. And we're just looking at the pawn right now. So we've got that player input player component. So now what we want to do is inside of that, we run the super, which runs the definition in the parent class that we're deriving from, which is what we want. And now we're going to take that enhanced input component enhanced input component. Oops. Enhanced input component. Did I declare that in the, did I have to get that in the, nope, I did not. Input component. What did I call it? Enhanced input component. Do I have to declare that in my header file? Nope, I did not. Where did I declare that? Oh, I need to load the header for it. And I need to, oh yeah, I'm not even loading it up. So I mixed a few steps here. So enhanced input component, I should have it, but I've got to get it first. So we're going to load it up by going if new enhanced input component, enhanced input component, pointer, so I'm casting the U enhanced input component just like we did in the blueprints. It's from the player input component. So if that's the true, then I now have enhanced input component, and I can bind the action. And it's going to be called move action, I believe we called it. And it's going to be on the triggered event. If you remember in the blueprint we had on the triggered event, I can show you that. This and it's going to be going to a FPS pawn move. Is that what I called it? AFPS pawn. Oh no. So this will bind it. This is creating that custom event that will bind it to this move event. So anytime this button gets pressed, it's going to call this event, which will just print out user input for now. So this binds that event. This does the equivalent of, let me open that up again. Of binding that event. So I'm going to, while that opens up, go in here and I'll try it out. I'll see if we're going to clear our log. I'm going to hit play. I'll click in. I'll click one of our keys. I don't see it printing anything yet. Okay, figure out what we're doing wrong in a second, but I will, in the meantime, show you what I'm trying to do. So that binding, that step is creating this IA move. So that every time that event gets called, it binds it to that move function that we've created, right? In our pawn, we've created this move function that isn't exposed, but it gets called through this binding. So it calls move, and move then prints this text. And let's just double check that. I'm not quite sure why that didn't work. Let's just compile everything. So I've been compiling with Shift Control B, but I can also compile from the Unreal Engine by hitting the recompile code and just make sure it's doing that. Nope, I'm getting a bind action error. Okay, that's why it didn't work. I do have a problem in my bind action enhanced input component. Bind action, and did I call it move action? Yep, move action. I did. And e-triggered event. E-trigger event. Do we need to load that in the header trigger events? This, and then a FPS pawn move, which is the name of this function. That is correct. So why are you not compiling? Oh, geez, I've got the pointer in the wrong spot. That's not good. That is correct. I do have the pointer, and I have the name twice. That's not even close to being correct C++. So this is a U, again, a struct, U enhanced input component pointer called enhanced input component. And now I'm going to build it again. It's looking a little happier, maybe. Yep. Now we can test it again. I can go to the game. I can clear the log. I can hit play. And I can see I'm getting user input. So I am printing out those values. That's good. So we're going to take it a step further and start to print out the values and make sure that our X, Y axes are working correctly on our movement. So we're going to go back here. We're going to go back to our code, and we will replace this printing with, we're going to first get our vectors. So we're going to go const f vector movement. It's a const because we're not changing it. And when we don't declare it in the header, so if we declare it in the header, it stays around for as long as the class exists. But if we just declare a variable here, as soon as this move falls out of scope, it's going to free up that memory. And it's going to keep it on the a stack and not put on the heap. So if you don't need something for more than one frame, it's best just to declare it here. And since this changes every frame, because it ticks every frame, we'll just leave it as a const vector. So we're going to go, F movement is our forward vector. And that's like our get forward in the blueprint. Forward times movement vector y. Plus right times movement vector dot. Whoa, it keeps changing it. It's not what I want it to do. I want this to be movement vector. Oh, I didn't declare them. That's why. So first I gotta convert my 2D input to 3D movement, forward, back, and left, right. So it's going to be const f vector forward is equal to get actor forward vector, and we have that in our blueprint. And const f vector right is get actor right vector. Get input from controls. So const f vector 2D. So it's a vector 2D movement vector equals value. That's this coming from the input. And we know that input's giving us a 2D vector because that's what we set it to. So f vector 2D. So we get our values from the controls in this 2D vector. We get our forward and our right vector, and then we basically multiply forward and right by our movement vector y and movement vector x. And then what we're going to do on the print, just to double check that we're doing everything correctly, we are going to, let me just load up the game again on the other side, just to show you the conversion side by side. Okay. Let's go in and just get that. Okay. So we're going to go move input. And we're going to put two variables because we want to print the x, which is going to be a float. And then we're going to print y, which is a float. And then we're going to add movement vector x and movement vector dot y, capital Y. So I'm going to print this out and just make sure that this is correct. All right. So this is just creating that vector called movement. So we're doing nothing with that now. So first we consume the 2D input, which is this x and this y value, capital X, capital Y. And then we get the forward and right vector, and that's very similar to what we did here in the game. We basically get the right vector, we get the forward vector, and then we're getting these x and y values. So we're just getting these values from these pins and getting these vectors, and then we are going to add our movement input. And we did our movement in one. We can do it in one function rather than these two functions where we had to separate our X and our Y. That's one of the advantages about using C++. We can pass it more complex structures. So I'm going to go back here, and we are going to compile. I'm going to clear the log. And as soon as it compiles, yep, it succeeded. We're going to stop and play again. And now I'm pressing A, and that's going -1 on the X. I press D, and that's going +1 on the X. I press S, that's going -1 on the Y. I press W, it's going +1 on the I. And then I do the same thing with left, right, left, up, down. So same thing on the left. So it's doing everything I expect. So we really only have one thing to do, which is to essentially add the movement. So call the function we called here, add movement. So add movement input. So in C++, all we need to do is we can comment this out. We don't need this print anymore. This was just to show that it worked. That's good. It does. And now we can go add movement input. And that takes a vector 2. So we just add the movement. And it adds both the X and the Y movement. So now I go compile. I go in the game, I hit play, left, right, down, up, left, right, down, up. All 8 keys are working, and diagonals. So perfect. It's doing exactly what I expect it to do. That is really good. All right, let me look at my notes. Okay, let's finish up by doing looking around, jumping, and sprinting. So looking around was camera POV, so we did an IA look, and then we added a controller yaw and a controller pitch. So we're going to do the same thing, but in C++. So we're going to go in and let's go to our project, and let's create let's create all our actions, just get them out of the way. So let's go input, and we're going to create input action, and we're going to call it IA look. And that again is going to be a vector 2D, so not a digital bool. And then we're going to save that. And then we're going to create a input action called IA jump, and that will be a Boolean, so we can leave the default values as is, and an IA sprint, which will be a Boolean, and we can leave that again as it is. So IA, input action underscore sprint. I'll be for sprinting. So let's first look at looking around. So let's go to our IMC default, and let's close this, and let's add another mapping. And this one is going to be for IA look. So this is going to be for looking around. We're going to go save. And now we got to create a link to it. So in our player pawn, we had our link being in our header file. And in our header file, we had it basically called a move action. So we're going to call this a look action. Look action. And that's going to need a definition. Whoops, it's not up quite yet. Oh, not up quite yet. It'll be there soon. Takes a little time sometimes for it to catch up. Anyhow, I can go in, and we also need to go in and set up another. So we're going to have to do a void look to bind to the same parameter we pass to move. Now let's not misspell it. Look like this. Oops. Can I take this look action? Oh, this is a property. This is not a function. There's nothing to There is nothing to, didn't mean me to press that. There you go, generate definition. So we got our look. We're looking around. Okay, so we're going to have to go here, and looking around is going to be untriggered as well. So instead, this is going to be look action, and it's going to be on a triggered event. And it's not going to call move, it's going to call look. So we've got to compile. And since we created a variable for look action, we're going to have to assign it in the editor. So we've got to go to our editor because it's not assigned yet. And we don't want to forget that. So we want to go to our, whoops. Our editor, and we want to go to our player, FPS pawn, and there's a look action. And we're going to assign IA look to it. And IA look has, that's going to be a mouse 2D. So mouse 2D axis. So the mouse 2D axis is going to send values to it. And essentially that look function is going to mimic our blueprint where we adjusted the yaw and the pitch. So we're going to do the exact same thing. So first we got to get access to that vector just like we did last time. So let's go back to our C++. Let's go back to our definition. And we still need our f vector 2D. So in our look function, that's the first place we're going to start, is get that f vector. And then we pass our yaw and our, if we look at our, it was add controller yaw, add controller pitch input. And it's very similar in C++. So nice, it's going to be add controller yaw input. And then we pass that look action X. And add controller pitch input, and that's look action dot y, not dot y. Why is it not liking dot x and dot y? Look axis vector. Oh, right, because this shouldn't be called movement vector. This should be called look action. And there we go. So the X controls the yaw of the camera. That's the rotation this way. And then Y controls the pitch. So I'm going to go in and I'm going to compile. Whoops. Compile. It's looking happy. Nope, it's not. Look action. C declares look action hides class member. Okay. I've got a problem. My look action hides member. Mm-hmm. What have I done? What have I done? What have I done? Oh. Look action I'm using twice. Oh, what is it saying? Look action. Oh, I had the same name. Okay. So I don't want to call this look action then. So I'm going to call this look vector. Yep. Can't use the same variable name twice. Fair enough. Okay. I can go to the game. I can hit play. And up, down, left. Oh, this is the wrong one. That's the good one. Let's go to the one we're working on. And we're going to go play. And left, right works. And then down goes up and up goes down. Our Y is reversed. So if you remember in our last project where we did it as a blueprint only, we had to reverse negate the I. Now we could negate the I, but I could also just go into the code and multiply the y-axis by -1. So pitch is backwards, invert axis. So and that's just easy. Multiply by -1, and that'll invert the axis of y. And that's a little quicker than going and messing around with our data, and does effectively the exact same thing. So now when I run and I go up, it goes up, down, down, left, right. So I've got looking and moving all working correctly. Okay, let's add jumping. So let's go back into the game. Let's go here. And let's go to our header. And let's add a jumping and a sprinting action. Let's just do both. Jumping and sprinting, because we've made both of them. So we may as well go jump action and sprint action. Compile it. And then we're going to assign the actions we created, because we did create the actions for them. So that looks like it's compiling. So we can now go to our pawn, and jump gets jump, and sprint gets sprint. And then we can go to our IMC default. We can add our controls for that. So we can add our two mappings. Whoops. So this is going to be jump. And then we can add, oh my gosh, I hate how it opens everything up. We're going to add sprint. And then our jump is going to be the spacebar. So nothing special. And then our sprint is going to be, we'll use shift. I'll do the left shift and the right shift. Oh my goodness. Why do you open everything up? And then here, right shift. So left shift, right shift for sprinting. So we've assigned our keys for jumping and sprinting. Let's start with jump. So go back to our C++ code. We've assigned that action. So we can go back to our CPP. And actually we can create a void jump. Actually, let's just copy and paste this and then add a jump and a sprint. So jump and sprint. And then we can add definitions for these. There we go. And now we can go up here and we can go next input component. Actually, we can just again copy and paste. So let's look at jumping. Actually, you know what? For jumping, we're going to need two functions for jumping. We're going to need jump start and jump end. Actually, we're going to need sprint start and sprint end too, because we got to change the speed at the end. We got to end the jump and end the speed boost. So we're going to need jump start, jump end, sprint start, sprint end. So that's going to be start, start. And then we're going to need, I could create it in the other screen, but I'm already here, so I may as well just do it by hand. Create that definition for jump end. And then create a definition for sprint end. Not sure why that's, I think I spelled that correctly, but it's, Ryder is telling me I spelled it wrong. Oh, I don't need void on it, do I? I do. Must have had a spelling mistake. I just didn't see it. So what we're going to do is we're going to start with jumping. So let me just compile, make sure everything builds. We're going to bind our jump. Okay. So let's go back here, and this is going to be jump action. And instead of on triggered, this is going to be on start, I believe it is. Started. And then we're going to need, so it just runs once as soon as the button's pressed, and then it's going to end the jump as soon as it's completed. It's going to be on completed. So this is on the button. This triggers, so as long as the button's pressed, this is firing every frame, it's ticking. This only runs once on the start, this only runs once on the complete, and it's binding to jump start and jump end. And then literally, if you remember the original blueprint, I don't think I have it here, do I? Nope, I do not. It just calls jump and stop jumping. So it just calls jump and stop jumping. So that's all we need to do. And that's what the blueprint did. It's called jump and stop jumping. So let's compile. Make sure it's happy. Oops, it's not. It does not like not quite sure why. It's not happy. Jump start did not get declared. Okay. Oh, well, I put that in sprinting. Well, that's silly of me. And you're kind of right. Where did my jump start go? I must have gotten rid of it. So I am getting tired. Jump start. So we're going to move this to jumping, not sprinting. That'll help. So jump start and jump end. And that worked. Well, we'll see if it worked. It compiled, let's put it that way. So I hit run. Oh, that's the wrong game. Oh, right here, I can show you actually what the blueprint did. So the blueprint for jumping, called jump and stop jumping. That's exactly what we've done. in that bound event, we've just called jump and stop jumping. So go back here, we'll hit play. I'll jump. There we go. So it works. Let's add sprinting. So for sprinting, we are going to do a sprint. Again, an end and a start on the sprint. And I'll remind you what the code looked like. So this is going to be sprint action and sprint action on start and end. And this will be sprint start, sprint end. Sprint start, sprint end. So in sprinting, we basically set two variables, max sprint speed that we set to 2000 and max run speed that we set to 600. So sprint speed of 2000 and a max run speed of 600. And then we just change the character movement. Now we're going to have to get the character movement class, and that's a little bit trickier. So we're going to do that right now. We're going to grab our character movement class. By getting the character movement component, which is not directly accessible. We're going to have to cast to it. So we're going to go to our pawn, and we are going to go U property, visible anywhere. So basically, we're not going to edit it. So we're not going to allow it to be read or written, but we're going to be able to see it. We're going to make it visible everywhere, or anywhere, I should say. And whoops. And it's called U character movement component. And we'll call that pointer character movement component. And now we've got to grab that. Do I have to forward declare that? I might have to. Nope. It looks like it. I may not. So I'm going to go to my definition now. And in the constructor, we have to do a bit of fanciness here to get that camera component. So let's get that camera component. Let's go create. No, not the camera component. We need to get the character movement component. Actually, we're going to do that in begin play. So in begin play, we're going to do character movement component equals, so we're going to cast to U character movement component, and then we're going to get movement component. So it doesn't come to us at the exact right level where we got access to all variables like max walk speed. So we've got to basically cast to that. So we call a method they've given us, a getter function. They probably made it private. So we can get that, and then we cast it to character movement component, which will give us all the variables in our character movement. And if you remember, that was the walk speed in our character movement component was right. Walk speed, max walk speed was right here. So we're going to go from 600 to 2000 back to 600 again. So that's the character movement. So let's create two variables. We created two variables, right? They were so we're going to go U property, blueprint read write, edit anywhere. So we'll allow the person to edit it. It's category this time. It's not controls, it's movement. And we have to go meta equals allow private access. Allow private access equals true. And then we're going to call this float max run speed. I know they call it walk speed, but I think we're running and sprinting. I'm just going to change it to something that my brain can understand a little better. So max sprint speed. Okay, And I'm going to set our default values. We can override them in the blueprint. That's the magic of this, right? But I'll set the default values to what I think I want. So I'm going to go over a suggestion. And it defaults to 0, and that would be bad. It's just going to stop the player. So we want to leave those blank. So max run speed, max sprint speed. So max run speed is going to be set to 600. And it's a floating point number. So we want to basically do a float. In C++, if we just do 600 dot 0, it's a double. And if we do 600, it's an integer. And it casts the variable. And we can have some small little discrepancies. So I always want to keep my type consistent. This is a float. So I'm going to assign it a float. And then max sprint speed is 2000. 0f. So we've set our max run and max float speed, and we've got our character movement component. So in our character movement, we can go in and on sprint, we can go character movement component, and it's max walk speed equals, and it was the run speed. Oh, what do we call it? Max run speed. So when sprinting, actually it's going to be max sprint speed when we're sprinting. And then when we finish sprinting, we're going to go back to max run speed. So up to 2000 and back to 600 by default. And let's compile, and let's check our defaults, make sure that they are actually carrying over to the game. It is the constructor, so sometimes you might have to run the game again to get it to work. So I'm going to go here and look at our player. And max, nope, 600 and 2000. It's set. That's good. So I should be able to go into the game, hit play, and then hit shift. Oh yeah, and it speeds up, slows down, speeds up, slows down. Yeah, nice. Okay, so I've got that working. Now there's something here. If you notice, we've got this mesh and we're never really using it. And in blueprints, we couldn't do anything about it. We were stuck with that. We were stuck with that mesh in our blueprint version of the game. So what we can do is we can actually get rid of it. So we can go here, and in our C++, we can actually destroy that component. I'll show you how to add a component in a little bit, but let's just actually destroy that component in the constructor. So I'm going to save, because I think I might crash things. I want to save and push to force just to be on the safe side. So we're going to go save, check everything out, submit all this work. So this is added jumping, sprinting, and looking. Yep, I've added all three things. Perfect. And then I submit the change list just in case it crashes. And then I'm going to go here, and in the constructor, I am going to go okay. So this is sets default run and sprint speeds. Pretty self-evident, but you never know. And then I'm going to go remove mesh component as it is not needed. So we're going to go get mesh. They've made a getter for it. And then to destroy a component, we don't destroy it using C++. We call the garbage collector that Unreal uses, which completely destroys. Whoops, I have to spell it right though. Destroy component completely destroys skeletal mesh. And I'm going to compile and we'll see if the game blows up or not. I might have to rerun it again for it to actually load or reload it. I'm not sure. Let's just make sure it compiles. Yeah, looks like it. So it's gone. Nope, it's still there. Let's close it. Oops. Oops, no, that's fine. And I'm going to go to blueprints, pawns, load it up, and it's still there. I think if I load it from scratch, it's going to work because the constructor has run already. So I don't think just loading it and unloading it stops it from stops the constructor, because it does go into their garbage collection, which might not garbage collect it right away. So the constructor has already run. So I think if I run it again, it's going to hit this destroy component as soon as the game loads. So it does not like me having 2 games loaded. So when that second game stops me from compiling, so I have to close that second game. Otherwise I can't do the code injection. I believe that's what's going on here. Let me just double check. Sometimes it just takes a few more tries. Yep, looks happier now. Starts to load up Unreal. And I'm hoping it gets rid of the skeletal mesh. Then the last thing we're going to do is add a camera, because if you remember, there was no default camera that came with the pawn. We want to adjust the camera position to where we want it. We might want to do some other things with it as well. So we are going to go back to the game, and we're going to load up our player pawn and open it in the full blueprint editor so I can see it in the viewport. And sure enough, it destroys that skeletal mesh, so we no longer have it, and it's no longer taking space. That's great. So let's see what it's like to add a component. We added a camera component to our other project, so let's add a camera component here. So we're going to go back to our .h, and we are going to add a camera component. Where did I add that? It was okay. So we're going to add it. So we're going to go uProperty, visible anywhere. Don't need to edit it. But I think I still think you can edit it visible anywhere, actually. uCamera component. Whoops. Add the include, yeah. uCamera component, star. Camera component. Actually, I don't want to add the include in the .h. Let me put that into the CPP file, and we'll forward declare it instead, since I'm not doing anything with it here. I can basically go class uCamera component. And that's a uObject class. So uCamera component, which is I added up here. There we go. Okay. Now that doesn't actually add it to the game. If I played the game, it's just an empty pointer. So I've got to actually instantiate it. So I go into the CPP, I can go into the constructor, and we're going to add camera player pawn. And we're going to go camera component, and we're going to make it create default subobject. And that's how we add, and it's a uCamera component. And we've added the header file for it. And then we're going to go text, and we'll call it camera component. Let's call it camera. Text camera. And let's compile. And again, we might have to rerun the game because it is in the constructor. We might actually have to bind it to the top to put it in the hierarchy. It might not just pop in automatically. So we're going to go here, and then we're going to go in and check the game. And I do see a camera component called camera. there we go. It is actually there. So we didn't have to recompile. That's good. And I should, for good, I should always set it up as an attachment so it knows the hierarchy. I think it just puts it underneath the main, but it's always a good idea to set it up. So we're going to go camera component, and it's called set up attachment. And we could attach to another component, make it a sub of that to change the hierarchy, just like you can in blueprints. So set up, so essentially it's, so we got it, it's the capsule component, and they've made a getter for it. So we're going to make it a child of the capsule component. Get capsule component. Why is that not? Capsule component is incomplete. Not sure why that is the case. So camera component, set up attachment, get capsule component. This is in the pawn, yeah. Why is that not pointed incomplete type? Huh. Let me compile, see what ChatGPT says. Not coming to me. Brain's not working. Really? Huh. It was working last time I did this. I didn't do that. I did not need to do that. It actually worked properly, but I'll trust it. I had this compiling before. I'm not sure why. It is not red anymore. Not sure why it worked for me before. Okay, all right. Well, essentially it needs to cast it to a scene component. So I'll take it at its word. And it really should do nothing because it was in the right spot. It is under the capsule component. It's not under the arrow component or something that it shouldn't be. So that's fine. And then if you remember, the camera shouldn't be above, it's up and a little bit forward. So if I remember correctly, it is camera component. We're going to set the relative location, and it's going to be a vector. So in CPP, it's an F vector, and it's going to be 15 forward on the X, 0 on the Y, and 70 on the Z. Let's compile. Succeeded, and I don't see it move because it's in the constructor, so it wouldn't surprise me that it won't move until I reload entirely. So let's do that. Let's stop it and reload it. And let's load up our player. And hopefully the camera's in the right spot. Yep. Camera is -40. -70, sorry, and 15. Perfect. So roughly where your eyes should be. That seems good to me. So I like that. I believe there's a few other things, 2 other things to do with the camera, and that'll be it for today. And then we can do the rest of the blueprint later on. So that's up and down, and our camera seems to work. So that's good. And our sprinting. Okay. So the final, actually, one thing I want to check is our yaw is broken. So I can't move my head up and down. Because if you remember the blueprint, we had to set the, what was it called? It was the pawn control rotation. So we had to set this to true. And then we also constrain the aspect ratio. So we could always see 16:9. So we set the constraint aspect ratio to true. So let's do that in C++ and get our defaults to be what we want. And they can be overridden in the blueprint. You can turn those on or off. So we're going to go camera component set, sorry, B use pawn control rotation is now true. That'll fix the yaw. Fixes the yaw. And then the last thing we're going to do is set aspect ratio to fixed. And that will be camera component set constraint aspect ratio to true. And essentially we're going to go compile. We might have to rerun the game again because it is in the constructor. So I do not see constraint aspect ratio. So we're going to have to reset. And so let's save. Save everything. Oh, it's saved. That's fine. And then start the whole game over. And then we'll be done. That's a good amount for today. I'm on tape. I'll be 5 minutes. Okay, so we're going to hit run, and you can see the aspect ratio is constrained, and I can yaw again. So that's fixed, and I can show you that. Aspect ratio, let's go into our editor where I can see it in the normal view. Our camera, our aspect ratio is constrained, and the pawn control rotation is true. So that's it. That's our first project in C++. And we will finish it in a second video. We'll do the rest of it. All right. Talk to y'all soon.